Separation of concerns is by far the most complicated part of business application development. Yet in this video I will show you one technique that makes it so simple that by the end of this video you will say, "Oh, this guy was cheating, it can't be that simple." I will show you that technique on an example which I really had in my career many years ago. The problem was about processing millions of files, literally millions of files. If you look at this picture, you will see several responsibilities. First, each stage of the processing is one responsibility alone. Each of those stages would have thousands of lines of code in that particular software. Then you see the engine that runs all this by accessing the files on disk. And you see this little thingy here that actually glues the processing loop with the processing stages and makes them run together. And the trick I want to show you is that you should also recognize the component whose sole responsibility is to join other components together. And then do what? You do what you do best. Create a class that does that. I will define a type which I will call checked because I'm actually running files through a series of checks by holding the current object model of that file. However, checking might fail, and so this checked type will also track a possible problem. It is super simple, just a line of code. But it is encapsulating an idea that there is an object whose sole responsibility is to track the current state of the content we are processing and any problem that may have occurred so far, so that there is no reason to process it any further. And then come the concrete variants, because checked is the abstract type. One concrete variant is the past variant, which indicates that all validations and processing steps have passed so far, and it doesn't have a problem object. The other variant is the failed one. It would have the content of the file and the problem that happened. And then come the operations on these types. These types must support the processes that you could see on that original image. So there will be the loop, there will be number of processing stages, and each stage could either report a problem or advance the object model into the next, more enriched state. And then comes that idea which I want to present in this video. When you see the system of types like this, you should know that those are the monads. This is one monadic type. And every senior programmer should invent a monad once in a while, just for the joy of it, because monadic types presented this way are truly simplifying your code base. Then we just need to implement two functions, two methods every monad needs to have, and the entire application will be able to use this system of types perfectly. It's very simple. Watch this. The first method every monad needs is so-called unit function, unit method. It initializes the monad from the value it contains. Just in the case of the checked monad, there is also the failed variant, but it requires two objects. One is the content of the file we are processing, but also the problem telling what's wrong with that object. The other half is the bind operation. Every monad must support bind operation, which does a very, very simple thing. It operates on the monad object and receives a function that applies to the content of that monad, so the file's content, and returns a new monad explaining the next stage of that same file's processing. That's it. You have the monad. It is also very useful to have a bind method that changes the type of the value wrapped inside the monad. The bind operation in this particular case that changes the result type will also receive the value that represents this file in case of the failure. So you see, it's not really straightforward. You need to understand your own problem, the problem you are solving, and then to define the unit and bind operations according to the problem you are solving. It is also useful, very useful, to define a map operation that just modifies, advances the file's state. And it is also useful to include a match operation that separately matches the past state and failed state. Now I need to implement the two concrete variants. Look, binding a past file means to just apply the function to the file's content. Changing the type of the content is also very simple because we would just apply the function to the object model. Now, mapping a function to change the type of the contained value means to simply apply that function to the value and wrap it into the new monad. And when it comes to matching one or the other variant, we match one, the past variant, and ignore the failed variant because this one is the past one. A corresponding implementation of the failed concrete kind is very simple and completely opposite. Binding a failed monad means to just keep it failed. There's nothing to do. This is very important because if you remember that pipeline of stages, once a stage fails, no other stage will be executed. So there will be the pipes in the pipeline, but they will just take the trivial path saying return this and retain the error that happened before them. That means that monads are also very fast. They are not doing things that make no sense, that make no result in a particular execution scenario. What's that? 20-something, 30 lines of code. And that responsibility is done. It's done for good in one place, so that now I can start using it. I will give you a few trivial examples just to have something to work with. Here's the idea. Every processing stage now has a mandatory signature. Receive one object model representing the current state of the file and return a checked monad with the new object model and the problem specification in case that the problem happened. A method like this is an obvious candidate for the bind operation on the monad. These are the toy examples, but the real methods would be very complicated, and not only that, but each of these methods would sit in a separate assembly, in a separate project. But now comes the time to use them. So this is the method that will process one file. You will now witness how simple the code will suddenly become because there is that checked monad that represents the central responsibility in the entire project. But before that, let me remind you that this video and all other videos on my channel are free, only thanks to the patrons who are supporting this channel. So if you like what you have learned from this video, and if you like other videos on my channel, then please join me on Patreon and become the sponsor of this channel that will give you access to the source code for all the videos on the channel, and also access to some discounts and other goodies that I occasionally offer. Let's see what we must implement to subject each of the files to processing. First, we must locate the file because it might not be there. And guess what? The locate function is also receiving file info, which is one trivial representation of the file's content, and returns the monad. The next processing stage, mandatory for all files, is to read them. Turn a file info into a sequence of strings, an array of strings. However, it's possible that reading will fail for whatever reason. If that happens, we would just return the failed variant telling there are no lines to show because we couldn't read them, and we are ready to go. I will include all the checks that must happen. That could be adding references to several other projects and accessing the services exposed by those projects. It's super trivial in my case, in my demo. And then we begin. Just locate the file. That will return already a monad that might indicate success or failure right at the beginning. And then comes the first call to bind. We will bind read to this information and either succeed or fail, or if the first stage failed, we would just supply an empty array as the alternative to the content of the file. This is the entry point to the actual processing pipeline, and what we do next is just to bind each of the operations, each of the stages in turn. Just bind, and the entire pipeline is over. And once the first failure happens, no further processing happens. That is the ultimate goal of every processing pipeline. And the central responsibility is implemented in these 30 lines of code. You see, I have captured that very sensitive responsibility into a monadic type that sits at the heart of the entire solution and takes one very complicated, one very especially dirty responsibility. It takes that responsibility on itself and does it to the end.